Hi, the objective of this video is to show you the idea of inverse functions. Yes, inverse functions. Firstly, let us recap what we have learned so far. As you know, function can be visualized as a machine where x refers to the input. The machine can be described as 3x plus 1, for instance, and fx refer to the output. This relationship between x, the equation, and fx can be described by using two notations. First, fx equals to 3x plus 1, or fx 3x plus 1. Both equations carry the same meaning. It simply means that function f maps input x onto output 3x plus 1, or it can also be interpreted formally as function f such that x is mapped onto 3x plus 1. Now, refer to the above function. It is consisted of two simpler functions. So, visualize the two simpler functions as two machines. Firstly, when we fit in x into the first machine, it will go through a process which is called multiply input by 3. So the output here is 3x. The output 3x become the new input to the second machine, and the second machine can be described as plus 1 to the input. As a result, the final output of this process is 3x plus 1. You see, when we visit a restaurant and enjoy the food so much, those who are good in cooking will try to figure out the ingredient of the food and the process it is cooked. This process is the inverse of the cooking process, and now we are going to inverse the process that we discussed just now. In order to reverse the process, the output will need to go through two simpler processes as well. So again, visualize these two square or rectangle, if you like it, as two machines. Firstly, we fit 3x plus 1 into the first machine, which can be described as the inverse of the second machine here. So is minus 1 from the input. As the result, 3x plus 1 minus 1, we get 3x. And 3x now become the new input to the second machine. And the second machine in the inverse process is the inverse of the first machine just now. So it can be described as divide input by 3. 3x divided by 3, as the result we get x. This process can be summarized as fx equals to 3x plus 1, or fx 3x plus 1. And this process can be summarized as the inverse of x, or so how do we describe the inverse processes mathematically? Well, let us follow the process. Let's start from x. After it go through the first machine, it will become x minus 1 divided by 3 divided by 3. And this is x minus 1 divided by 3. So now this is what we call the inverse function. Take note of the symbol we use: f negative 1, f negative 1. So this symbol f negative 1 simply means the inverse function of f, and there are two ways to describe the function. First, f negative 1 equals to x minus 1 over 3, or so this is quite similar compared to the notation for function f, where both can be interpreted as function f negative 1 maps input x onto x minus 1 over 3, or in a formal way, function f negative 1 such that x is mapped onto x minus 1 over 3. Now, let us examine the above functions by using a different approach or different lens. Fx such that x is mapped onto 3x plus 1. These can also be written as fx equals to 3x plus 1. Firstly, we need to write a tentative equation for inverse of function f in terms of y and x. So inverse of function f in terms of y and x is written as follows. So y is equals to 3x plus 1. Then we change the subject of the equation. 3x plus 1 equals to y. 3x equals to y minus 1. X equals to y minus 1 over 3. From the tentative equation just now. Sorry, it's not this, but this. We know that x is equals to the inverse function of f when the input is y. So this is equals to f where it simply means inverse of f maps y onto y minus 1 over 3. And if we change the input, we need to change the output here. Sorry, it's not the output, but the element of the output here as well. So that f negative 1 x equals to x minus 1 over 3. And this is how we change the input. So 3, we change the input of the inverse from y to x. Now let's look at the expression that represents the inverse of x. X minus 1 over 3. Surprisingly, it is the same of the inverse function that we found just now. In other words, we can use this method to figure out the inverse of any function by execute the 3 steps here. Firstly, write a tentative equation for inverse of function f in terms of y and x. This is what you need to do. Then we change the subject of the equation from y to x. This is how you do it. And change the input of the inverse from y to x. This is how you do it. Now let us inspect the following function. Function k such that x is mapped onto 3 times the sum of 2x and 4. This can also be written as function k maps x onto 3 times 2x plus 4. Step 1. Write a tentative equation for inverse of function k in terms of y and x. So the inverse of k in terms of y and x is written below. Then y is equals to 3 times 2x plus 4. So this is the first step. Now Second step, we need to change the subject of the equation from y to x. So this is what we do now. Step 2, change the subject so that 3 times 2x plus 4 equals to y, and 2x plus 4 equals to y over 3. 2x equals to y over 3 minus 4. So x is equals to y over 3 minus 4 over 2. After that, we change the input of the inverse from y to x, and these can also be written as k negative 1 of y is equals to y over 3 minus 4 over 2. And step 3, we change the input of the inverse from y to x. So k negative 1 of x is equals to x over 3 minus 4 over 2. And this is step 3. So remember the 3 steps here. Firstly, a tentative equation, and this is the tentative equation. Second, to change the subject from y to x, and this is how we change the subject. And thirdly, we change the input, and this is how we change the input from y to x. Let us consider one more function before we wrap up the lesson of this video. Let's consider the following. Function j such that x is mapped onto 12 minus 5x over 3. So these can be written as function j maps x onto 12 minus 5x over 3. Firstly, write the tentative equation for the inverse in terms of y and x. So j inverse in terms of y and x. Then we need to change the subject of the function. So y is equals to 12 minus 5x over 3. Change the subject. 12 minus 5x over 3 equals to y. 12 minus 5x equals to 3y. Negative 5x equals to 3y minus 12. Divide both sides by negative 5. So we get x equals to 3y minus 12 over negative 5. Now, since the inverse of j maps y onto x, so and now carry out the third step, change the input of the inverse. So change the input from y to x. So j is equals to 3x minus 12 over negative 5. Now, we have figured out the inverse of j. And now let's proceed to evaluate the inverse of j. So how do we evaluate this? Of course, we fit 4 into the inverse function. So we fit 4 into the inverse function and evaluate by follow. 3 times 4, 12 minus 12 over negative 5. So this is equal to 0. This means that inverse of j maps 4 onto 0. And this also can be written as j inverse function of j such that 4 is mapped onto 0.